So we end this section looking at problems where sometimes we need to find the boundary cutoffs, right, are given. Um, we want to find the boundary that cuts off a given area proportion, right? And so it's called what we call inverse normal calculations, doing it backwards. And so here again, how we would do it on StatCrunch, but I'll show you. And then of course, if you're going to use Z-tables, then that's another way to think about it. But we'll take a look at how to do that on ArtistStat and using StatCrunch. So we'll do that through some examples here. Find the Z-score that cuts off the highest 5% of the normal population. I'm looking for a Z-score now. And so here we're looking for a Z-score. So mean would be 0. Standard deviation 1, because that's when we talk about Z-scores, it's the standard normal. And we're looking for it to cut off the highest percent. So I'm looking for the score here in the middle, and I'm looking for it to cut off the highest 5%. So it's a greater than symbol. I want the right side. And so my Z-score is 1.645 or 1.65. Here is the top 5%, which is essentially what we're looking for on that problem there. And so that's where you get the 1.645. If we were going to use, the ArtistStat to do that, let me bring that in a little bit better. There we go. You're going to find percentiles and quantiles that we're going to find certain values. We want the upper tail, the greater 5%. Mean is 0, standard deviation is 1, and we want the probability that in the upper tail is 5%, and there's your 1.645 or 1.65 value there. It's that easy to get those answers there. Find the Z-scores that cut off the farthest 5%. So that's two values. Again, that's to the left and to the right, the farthest 5%. And so we're looking for the number here. This one, if you're going to use two-tail, there it is right there. And if you put 95% is inside, then you have the 5% outside. So the cutoffs are 1.96 and negative 1.96, right? That leaves 2.5% on each side. If you think about it, because it's 95% on the inside, 5% on the outside, and that's what we were looking for, the outside 5%. On StatCrunch, there it is there, you would clean that out there, and I'm going to put 0.05. It's going to calculate the inside 5%, sorry, 95. I need to put 0.95 in here. Again, those cutoffs are the same. There's the 95 on the inside. The outside is still 5%, 2.5 on each side. But there's your negative 1.96 and 1.96. And then we do the same thing here to answer these questions here. Here's the weights of children, again, born in California. Find the birth weight of a child at the 95th percentile. So we're going to use the 7.5 and the 1.4. So here you're going to put 7.5 is the mean, 1.4 is the standard deviation, and I want the 95th percentile, which is the right tail, the top 5%. Compute, and so you get your 9.802 answer there. And then of course here we want a upper tail, or the right tail, 5%, and it was 7.5 and 1.4 here, and then you get, again, there's your 9.803 that we get. And you can see on the graph, again, important to recognize that this graph represents the full population of babies that were born, and so you can see that's the cutoff score to get the top 5% of the 95th percentile. 95th percentile or top 5%, however you want to see it there, and that's where those numbers come from. And then you can go ahead and then finish this on your own. You have the answers here. X equals 148. You should be able to replicate that using those means and standard deviation. Higher than 30% of all males, and so you're looking for the probability that it's greater than 0.30. And on this one, if their blood pressure is higher than 140, right? And this was the probability the random select has high blood pressure, and that one's just calculating the probability that X is greater than 140. You're given the X value here. You're given the percent, and you're trying to find the X value. Here, you're given the X value and trying to find the percent, just to recognize both those problems.